Welcome to this video. We are going to be looking at SonarQube. SonarQube is one of the tools that you use them as a DevOps engineer. And SonarQube, we use it for what we call static analysis of the code. Again, just like how we did in Jenkins, we are going to be running this SonarQube as a container. Of course, we are going to run it in detached mode. This is why we are using -d. And then we are going to use the name, --name. This is what we call a flag. And the name, of course, is going to be SonarQube. It's important you understand that we use -p, which is another flag to indicate the port. Here we have what we call 90,000. These are nothing, but they are two ports, internal and external and internal. And then we have another port, 9092. And then you might be asking yourself, what is the use of this 9092? I'm going to come back to this and answer these two questions about these two ports. And then, of course, we are using an image called SonarQube. So the question is, where can you get this SonarQube image? And the answer is very straightforward. This SonarQube image can be gotten from Docker Hub. Let's see whether this is possible. So we're going to come here and then we'll say Docker. Let's see, if I say Docker, is that enough? Or I need to add the word hub. All right, sure, it was there. I think I went too fast. So I might have to go back. Yes, here it is. And you're going to see that it's also a very famous container because 500 million people has downloaded this. So this is why we are using this. This is the image. It's called the SonarQube. Now, let me answer the question about the ports. We have port 9000 and we have port 9092. Port 9000 is what we are going to be using to access the SonarQube interface, or what we call the user interface, or what we call the SonarQube console. Just like what we saw in the Jenkins, we are using port 8080 to be able to access the Jenkins interface, or what we call the UI. And that one, of course, we can access that straight up from the web browser. Then we have another port, and this is port 9092. And this port is nothing but is used for communication between SonarQube and other tools in the CI/CD pipeline. If you are not familiar with what CI/CD pipeline is, you might need to visit my notes or my videos where I have done the CI/CD pipeline. But CI/CD pipeline stands for Continuous Integration, Continuous Delivery Pipeline. It is a pipeline that has become very famous in the SDLC processes of what we call the software development life, SDLC life cycle. Of course, this is just the whole process of building the software. That's what we call SDLC, software development life cycle. So this pipeline is very important because it helps to automate the process. And it is a series of steps. And you have to know the reason we are creating this kind of automation is always geared toward making sure that we can automate things that are very repetitive. When you are building the software, the pipeline is always almost the same. So you have a lot of activities that you do them repeatedly. So we can come up with a CI/CD pipeline, we can fasten the process of delivering the software because we can automate those processes. That's exactly what the CI/CD pipeline is. Now, the next question is, why is it called a pipeline? And it's called a pipeline because it's supposed to fetch something from one end and deliver it to the other end. And I'm not talking like, I want you to look at it like a pipeline of water. You can just attach the pipe to the water tap, And of course, it can deliver the water to another location. So this is why definitely we are calling this a pipeline. But this is not like the pipe of the water. It's very different. It is actually a combination of many tools that have been integrated together to be able to carry the entire process of SDLC in an automated way. So we have different kind of softwares that are brought together. They have been integrated together. And as a result, we can start one step here, and the rest of the step can be finished by the pipeline itself. One of the two that is going to be inside this pipeline is the SonarQube. And as we saw, SonarQube is a very essential tool for DevOps engineers because it helps us to have a way to be able to check the quality of the code. When we are able to check the quality of the code, we are also able to maintain the security of the code. Now you might be asking yourself some questions like, what quality are we checking here? What are we checking when we talk about the quality of the code? Of course, we are checking for bugs. We want to make sure that our code doesn't have bugs. Because if it has bugs, of course, we are going to have security issues. And if we are going to be delivering software that has security issues to the customer, that software is not quality. And of course, it's not going to give us the best services. Now, here we are going to see the reasons why you as a DevOps engineer, you need to be aware of SonarQube. The first one is code quality analysis. Of course, SonarQube is very famous for performing what we call static code analysis. Whenever you hear the word static, it means that this is a code that is static. It's not the code that is running in the operation. This is mostly a code that is somewhere in the version control system of your choice. We can say, for instance, in the GitHub. And of course, it's going to run a quality check, or what we call analysis, and it's going to be checking for a few things. These things are bugs, code smell, and vulnerability of the code. Now here we have a crazy term called code smells. What is code smell? Does a code smell? Yeah, it does. But the only tool that can be able to know whether the code is smelling is SonarQube. And how does what make the code smell? It's nothing but the presence of the bugs in the code. If we have any bugs in the code is going to smell. Vulnerabilities, we are checking to see how this code is written. We don't want people writing the code and duplicating the code blocks or sections. We want to make sure that when you write the code, you are following the standards that are required in the industry. And again, this is something that SonarQube is able to do. Then we come to continuous inspection. It's able to do continuous inspection because it can be part of the CI/CD pipeline. You can integrate it with the CI/CD pipeline, and any new code that is added by the developers has to go through the process of building and, of course, scanning the static analysis of the code. And that means that there is no any code that is going to be added into the repository that contain the quality code without it being scanned. Security vulnerability detection, of course, is able to detect the code that is vulnerable, the code that is duplicated, the code that is not written in accordance to the standard of the industry. Technical debt management, this is a key term. If you're an investor and you want to invest in a software, this is something you have to always ask. What is the technical debt of this software? What is a technical debt? A technical debt, I can define it in a very simple way. Let's say we have developed a software today. If you look at the software, you go and you see that this software has a technical debt of 200 hours. If you are paying the developer $50 a month, and this software has a technical debt of 200 hours, which means these are the amount of times you are likely to spend maintaining the software, that software has a technical debt of 200 hours times $50. And this is just hypothetical. We are just saying, but that's happened. So it is about a technical debt of $10,000. So if you are going to invest in that software, you have to kind of consider all these things, because if the maintenance is that amount of time, of course, you have to hire people who are going to be maintaining the software, and those people will be costing money. And that's what we call the technical debt of the software. It's also very important in code review and collaboration. As you can see, SonarQube is going to offer some features that we can collaborate, DevOps engineers, we can get the feedback, we can see how the code quality is. And this again makes the software that we are developing to be of high quality. Continuous improvement, as we always say, maybe a DevOps engineer, continuous improvement is part of your game. Continuous improvement means every day you are improving yourself. That's simply what it means. And SonarQube provides us with actionable insight and metrics that, of course, help us to improve our code quality on a daily basis. So that's what it is. This is what SonarQube is. These are the advantages of using SonarQube as a DevOps engineer. We have seen the port numbers. We have seen 2 ports, 9000 and 9092. One is for web interface, the other one is for communication with other tools and the CI/CD pipeline. With that information with us, it's now time to go to our server, launch a server. We're gonna launch a server on AWS. This server is going to be SonarQube Server. And then we are going, of course, to run the SonarQube as a container. And then from there, we are going to access it through the web interface, and we are going to see exactly how it looks like. To do that, it's very straightforward. We are going to come to our AWS, and we are going to launch an instance. And this instance is going to be called SonarQube Kernel. And now we move forward. Again, we are going to use Ubuntu AMI. I love Ubuntu. It's a good AMI. It's usually a good, it has a good operating system. Now from there, we need to choose, of course, the size. We are going to use 2 vCPU, and we are going to use 4 GB of memory. That would be enough. And I'm trying to see the best one for us here. Yes, use 2 CPU and 4 GB of memory. Again, make sure you have your PEM key, and your PEM key is actually in a folder that you can access through the Visual Studio Code. Do not forget to edit your network, because if you don't give your instance a network, it will not be accessible. Make sure that your network is not private, because if it's private, you are not going to be able to access the instance over the internet. So we are going to enable this. Again, if you don't enable this, you are not going to have an IP, a public IP address, and that again will create a problem for you, because you'll not be able to access the instance through the internet. Now we launch. I have nothing else here to do except to click on the instance ID. And from here, what we need to do is to give this time. But as we did with Jenkins, we can simply just come highlight here. And then we go and be working on security group as we wait for this instance to initialize. On the security group, we click on it. And then from there, of course, we can go and edit the inbound. Only the inbound, don't worry about the outbound. We are going to add 2 rules. 9000 is a custom TCP protocol, any kind of traffic as far as coming through this port. We're going to add another one, which is for internal communication with other two in CI/CD pipeline, 9092. Again, we are going to put that one there. And then we are going to save this one. After saving it, let's go and see. We come back to EC2. Here we have one running. Of course, we know what it is. And then, as you can see here, If I come here and refresh this, it's still initializing, but it's okay. I still think we can get access to it. So again, exactly what you need to do is to go to your Visual Studio Code. For my PEM key is here. If you don't have your PEM key, make sure your PEM key is in the folder that you are going to be in when you access the terminal of your Visual Studio Code. Let's see what this means. Going to come here and say new terminal. Okay, you see where I am? I'd like you to come here and click on Git Bash. Git Bash is a bash terminal and give you some, you can do some bash commands here, which is much better. And now I'm going to do ls to see the list of all the folders and files that I have here. And of course, my PEM key is here, which make my work easy. So I'm good to go. Before I can access or before I can have any attempt to try and SSH into this server, it's very important I remind you about the permissions. So we are going to do something we call chmod. Chmod is nothing, but it's a command that we use to give file and folders permissions. I'm going to be using binary permission. You can use explicit, it's up to you, whichever one you like. For my case, I love binary permissions. Binary means they come as numbers. Now here you look, we have a binary permission of 400. What does this mean? One, I want to let you know that these numbers, they are 3 because they have a reason to be 3. The first number represents the owner's permission. The second number represents the group permissions. And the final 0 represents the other's permission. You have to remember that there are 3 permissions here. We have the read, write, and execute. Read is 4, write is 2, execution is 1, a total of 7. So if we did 777, everybody, owners, group, others, they all have total permission. But in this case, we just want, well, we want to protect this PEM key because this is a key to enter into our server. So we only want the owner to have the access to the key, but can only read, cannot write, and cannot execute. Then, of course, we need to put the name of the PEM key that you want this permission to apply to, and then enter. If you get an error here, your PEM key does not exist in the same folder that you are in. So what do? You double check and make sure your PEM key exists in the same folder that you are in. Make sure when you run ls, you can see that. Now we are almost there. So what do we need to do? We have confirmed the PEM key is there. We have added the permission to our PEM key. It's now time to go and connect with our server. To do this, we return back to our AWS. And now we can refresh to just make sure we are on the right time. We have the server already up. Initialization is done, and surely initialization is done. You highlight it. Quickly, you go to connect. You are looking for connect now. Yes, it's always gonna be here. Might change, it's not a must to be here, but always look at it here. Say connect, and then of course, there are many ways you can connect. Easy to instance connect, session manager, SSH client, easy to serial console. But in our case, we just want to do this from the outside, which is nothing but through the Visual Studio Code. So we are going to take example. I don't want you to be confused by this example. It's just the same way you SSH to an instance, but here we are adding -i. -i means nothing, but this is to tell the system that we do have a file name where our information is, the PEM key file, and that is this is the name of the file. So this -i, which is nothing but a flag, is to let the system know that we are going to be referencing to a file. Now we copy that, we come back here, and we enter. We say yes. And now we are in. It's as straightforward, easy, quick, very easy. it's good you check who you are. Who am I? I'm Ubuntu. But we cannot do much as Ubuntu, so we need to change it to become the root. We can do sudo su. Su means switch user. Now, if we do pwd, you're going to see that we are now in home Ubuntu. That's very good. That is actually your printing working directory, but you still want to know who you are. Who am I? Of course, you are the root now. That means you have the root privileges. Now, what do we do from here? We're going to be running our SonarQube as a container. If that is the case, we have to make sure that we have the platform that is going to allow us to run Docker containers. And that platform is none other but Docker. It's an advanced hypervisor. If you don't know what hypervisor is, there are some topics I have. Of course, there are some notes. Of course, there are some videos on hypervisors. And you can go and familiarize yourself with hypervisors. But Docker is an advanced hypervisor and is going to allow us to run multiple containers on the same server. Again, multiple containers in isolation, but in the same server. So now to do that, of course, we cannot run any container without Docker. Let's check whether Docker is installed. And how do you check? All you need is to run the name Docker, which is a binary, and see what happens. And of course, it's not installed. So the best thing about Ubuntu is that if a binary does not exist, Ubuntu will always let you know what to do. In this case, we are going to come and install this one. I'm going to pick .io, and then I'm going to add a confirmation -y, yes, and this is going to help me to avoid any issue that has to do with confirmation. I'm happy this problem happened because I'm trying to skip something that you should not. Anytime you launch a new server, there is something you must always do. The first thing is that you should always do the patch management. Why is patch management important? One, you need to update all the packages. Then, of course, you need to upgrade the system. If you don't do that, you're not likely to achieve the best performance. So how do we achieve this? Very good. We can either do this with a script. We can quickly write a Python script that is going, of course, to update the entire system. Or we can write a quick bash script that is going to do the same job. But I prefer Python because I can be able to use a clean sub process and all that kind of packages, and I can easily run the whole process of patch management. But now we're going to do this process manually because I don't have the script at the moment. So, but all my scripts are actually in the GitHub. You can get all of them, but we are not going to refer to them today. Today, we are going to kind of go manual. Manual is not the best way to do things, especially if you are in DevOps, automation and all that. It's always good to automate these processes so that you have time to do something else. But we'll do the manual. So we are going to run with apt-get, which is nothing but is a package management for Ubuntu. If you are running CentOS, you have to use YAM. So specifically, apt is for Ubuntu. So update, if you don't know whether you are supposed to confirm, you can put confirmation just in case. Now what we are doing here is updating the packages to the latest version. We just want to make sure all the packages are updated. Now, with that one, now we need to come here and run the next one, which is apt-get upgrade -y. Again, if you don't know whether you are supposed to have to -y, just put also. You can see there are a lot of things that needed to be upgraded. We are trying to upgrade everything to the latest version. And now when we do update of the packages, we are just trying to make sure that all the packages that we need are actually available in our operating system. So those are two things I would like you to get. When we do upgrade, we are just making sure that we are upgrading everything, upgrading the system all the way to the latest version. When we do update is nothing, but we are just making sure that all the packages, specifically the security packages that we need, are available in the system. It's almost done. Enter. In case you see something like this, just enter. And now we are done. And now with that, now we can come and check Docker. Of course, Docker is not going to be available. That was just a process of updating and upgrading the system. But now, let's see what happened. We had trouble the first time we did this without the patch management. And we solve it now. Let's see. Now the problem has been solved. So this is something I would like you to get used to. Always make sure that your server is updated, is upgraded. You have removed the old packages. You have removed the old plugins and all that. You have cleared your system, the cache, clean system. So those are the things we are trying to do all the time. And of course, we have gone through a lot of ways you can do this. You can automate this using the cron D, which means for the entire system, or you can use a cron tab, which specifically, of course, specifically is tied to your account, and you can always update, upgrade, remove the old packages, and of course, clear the cache automatically, maybe after every 5 days or so. So you have a lot of ways to automate the processes that you need. If not, you can use Ansible. And Ansible is even better because they can handle many servers. And this is why we always call it a configuration tool. Some people also like to call it an orchestration tool because it's able to orchestrate the servers. Again, don't confuse this with Kubernetes, because Kubernetes is an orchestration tool for containers, but Ansible is an orchestration tool for servers. So the names can always, people use different kind of names, but again, leave Ansible to be a configuration tool. Now, we're going to clear this, and now we check the Docker daemon, and it exists. We clear this. Cool. Now we are almost there. So with that one, we need to check something. There are 3 things you need to understand: Docker client, Docker daemon, and Docker socket. Docker client is here. As you can see, all commands start with Docker. So I'm like Docker PS. In the command I type, I'm getting the output. You're like, wow, how? It's very simple. The platform where I'm typing the Docker commands as input and getting the output so that I can read the output, that is what we call the Docker client. For me to type the Docker PS and get the output, it means that somebody is processing that information. That person that is processing that information is a service, and that's what we call the Docker daemon. But again, there need to be somebody that is a messenger, somebody that will listen to my information from the client and be able to send it to the processor, which is Docker daemon, and be able to receive the message from the processor and bring it back to the Docker daemon, to the Docker client. And that person is the Docker socket. So now we're going to check whether the Docker daemon is up, because if the Docker daemon is up, it will not be able to process anything. But because we are able to put Docker PS and get some output, I'm sure 100% Docker service is up. But let's check. To be able to check whether the daemon is up, we use the system sys here, status Docker. And as you can see, the daemon is up. If the daemon is up, it's always going to be triggered by the Docker socket, because the Docker socket is the one that listens and sends the request from the Docker client to the Docker daemon for processing. So even if we come and shut down the Docker daemon, is always going to be triggered again anytime we have a request sent from the Docker client. So the Docker socket, without the Docker socket, Docker daemon cannot know which information to process. And without the Docker client, Docker daemon will not be able to receive the request, or Docker socket will not be able to receive the request to send it to the Docker daemon. And so they all work together. 3 of them, they work together. So now we go to the last phase. And the last phase is where now we're going to run the Docker container for SonarQube. Again, these notes are going to be under the video. The link to access the information about the container is going to be under the video. So this is the command. You copy that, you come back here, you paste it, and then you run it. Of course, we don't have the SonarQube image here, so it's going to pull the image and then it will run it as a container. So we wait for it. It's downloading the newer image for the SonarQube. Now we go to clear this, and now we can run the Docker PS to check whether the SonarQube is up. Ensure the SonarQube is up and run. Now, what I want us to do is to go and access the SonarQube on the web interface. To do that, we're going to go back to where our SonarQube server is. We're going to click on it. And of course, I will highlight it. And then I need to get the IPv4 address. Of course, it doesn't start with 10. You see, if it was a private subnet, it will start with 10. But this is public subnet. And we enabled the IP address creation, which is a public IP address. So now we are not going to come here and use a private IP address. We are going to use a public. Now, we're going to have colon, and we are going to add port 9000. And port 9000 is a port, of course, where we can access the SonarQube through the web interface. And here we go. It's going to start like this. I think it's still trying to come up. All system operational, SonarQube is up. So it should allow us at least to log in. I'm trying to see whether they are changing anything. Okay. So we need to log in, yes. So to log in, I think is admin. Let me try admin. Okay. So it's going to tempt you, of course, to put the old password or change the old password. Admin, new password, you can put whatever you want. New password and then update. And here is our SonarQube. So these are the gates, as you can see. These are the quality gates. These gates are the ones that are going to be used to be able to kind of, you know, they are going to be checking how quality the code is. Quality profile, of course, these are all the things that will be used to check the profile of your code. When we come to CI/CD pipeline, you see how it's going to happen. Issues, of course, you can see bugs, vulnerability, code smell. Those are all things that are going to be checked by SonarQube. So this is very important too, as we have seen. And then, of course, for you to be able to integrate it with your CI/CD pipeline, there is something you are going to need. And this something that you are going to need is what we call, is what we usually, is like a secret, or is like a password, but you are going to need that password to be able to connect it with other CI/CD pipeline tools. And you are going to see this, especially when we come in the process of course creating the CI/CD pipeline. But I'm going to show you how to create the token. So to create the token, you are going to come to where you see the account name, my account. And in this process, you are going to come and look for security. And in the security section, you are going to create a token. So this is a token, type user token that it is, and generate. So this token is the one you are going to copy, is like a password. and you are going to paste it in Jenkins. And of course, there is a way. Of course, I'm going to show you exactly how to integrate the two tools so that they can work together in a pipeline. But this is how the SonarQube web interface looks like. It's a tool that, of course, we are going to use a lot for static code analysis. It's very important because it helps us to maintain high code. And of course, if we can be able to detect vulnerabilities of the code earlier, we are able, of course, to prevent many security issues that can happen with the software. And apart from preventing security issues that can happen with the software, we are also able, of course, to create software that is quality and is easy to maintain. With that being said, we have come to the end of this session, and thank you.